Okay, so we've looked at a process called differentiation. And differentiation was where, say we have this function f of x, which is equal to, let's say, 3x squared. And we're asked to find the derivative of this function. Well, the derivative, f prime of x, that's going to be equal to 6x. And we found that, and we know how to do that from previous videos. But now we need to do something called antidifferentiation. And antidifferentiation is taking something like this 6x here and asking ourselves, well, what is 6x the derivative of? And we've just seen here that 6x is the derivative of 3x squared. So we can say that the antiderivative of 6x is 3x squared. But how do we write this? Well, we write this, we say that the antiderivative, and we use this tall-looking S shape, we say that the antiderivative of 6x, with respect to the variable x, we have to put this dx bit in. Okay, so the antiderivative of 6x is equal to 3x squared, because 6x is the derivative of 3x squared. But there must be a way that we can do this all the time, and there is. We're going to come down here, and we're going to have a look at this table and see if we can recognize any patterns. So on the left here, we have what we call just our function. So we just have our f of x. And on the right here, we have our antiderivative of that function, antiderivative. And we're going to see if we can see any patterns that can help us always find the antiderivative. Well, to start off with, we can write this 4x as 4x to the power of 1. Okay, and we're going to see, let's see some patterns. So, well, this 2 to the power, so x to the power of 2, that 2 is 1 bigger than that 1 there, the x to the power of 1. And this 3 is 1 bigger than this 2 here. And this 4 is 1 bigger than this 3 here. So we can come up with the conclusion that we have to add 1 to the power of x. That's our first step. We always need to add 1 to the power of x. And the next thing that we need to have a look out for is, well, what happens to this 4? This 4 becomes a 2. And how does it become a 2? It becomes a 2 because we divide it by our new power. We divide that 4 by that 2 up there. So we divide this by 2. And the same thing goes. Here, we could put a 1 here, but to get that 1, we need to divide this section over here on the left, our function, we need to divide by 3, by our new power. And the last one, our new power here is a 4, so we need to divide by 4. And 8 divided by 4 gives us our 2 there. So we need to add 1 to the power of x, and then we need to divide our function by the new power. Okay, so let's do an example. Let's say that we're asked to find the antiderivative of, let's say, 5x to the power of 4 with respect to the variable x. Well, what do? We add 1 to the new power. We add 1 to the power to give us our new power. So 5x, we add 1 to 4, so we get 5x to the power of 5. And then we divide by our new power. We divide by 5. Well, these 5's cancel out, and we're left with x to the power of 5 as our antiderivative of 5x to the power of 4. So can we come up with a formula now that states this outright? Well, we say that the antiderivative of ax to the power of n, okay, so in this case our 5 is our a and our 4 is our n, with respect to the variable x, is that we need to add 1 to the power, so we get ax to the power of n plus 1, so we're adding that 1 to the power, and then we need to divide by our new power. We need to divide this by n plus 1. And this part here that I'll highlight in yellow, that's our formula for antidifferentiation. Okay, and that's pretty much it for antidifferentiation, but there's one last little part that I want to have a look at. And remember that we said that when we're doing the antiderivative, we're asking ourselves, what is that the derivative of? Okay, so for example, let's find the derivatives of these functions here. So 3x plus 2, 3x plus 4, and we'll do a couple more. We'll do 3x plus 100, and then we'll do 3x squared plus 1,000. Okay? Well, the derivative of 3x squared plus 2 gives us just 6x. Okay? And we'll just put the d over dx's out the front of all of these. So we're finding the derivatives of these functions. Well, the derivative of 3x squared plus 2 was 6x. And 3x squared plus 4, that's also going to end up as 6x. And the derivative of 3x squared plus 100, that gives us 6x. And the derivative of 3x squared plus 1,000 also gives us 6x. And that's because all of these terms here, when they take the derivative of them, you end up with 0. Okay, so when we're asked, what is the antiderivative of 6x? So what is the antiderivative of 6x with respect to x? Well, what is 6x the derivative of? It's the derivative of all of these things. It's the derivative of 3x squared plus 2, 3x squared plus 4, 3x squared plus 100, and 3x squared plus 1000. It's the derivative of all of those. But the way that we can write this is it's the derivative of 3x squared plus any number, any constant. So we say that this is equal to 3x squared plus, and we use the letter c to represent a constant. So that can be any number. And if we want to write this using our formula that we just learned in yellow there, we say that the antiderivative of ax to the power of n with respect to x is equal to ax to the power of n plus 1. So we add 1 to our power. We divide by our new power, which is n plus 1, and then we have to add our c on the end. And that's the crucial part, okay? We always have to add that c because we can have any of those 4 things on the left there going, or any however many things. And that's the common thing that a lot of people miss out. So don't forget to add plus c. Well, that's it for antidifferentiation. We add 1 to the power and we divide by the new power. Thank you.